Hi, welcome. My name's Craig Forster. I'm a cloud solution architect here at Microsoft Denmark. We've had quite a number of news events, I guess you'd call them, in the last couple of months around the topic of denial of service attacks. So what I thought I'd do is walk you through quickly what the services that we have inside Azure that could help you, whether you've got Azure or not, whether you've started using it or not. There's some ways that we can start getting you to use Azure nonetheless. Yeah. So what we'll do is we'll start talking about what is a denial of service attack very, very quickly, and then progress through around, hey, what are the different offerings that we have in Azure? They could be things like, we've already got something. Do we need to pay for anything on top of that? If we do decide to pay for something, what more do we get to help us? And then we're going to walk through some of the different potential architectures you could use once you've got Azure DDoS spun up, to make sure that you could be protected without having to go and do a whole lot of lifting. You could effectively come in and start being protected by a DDoS protection plan right away. So let's kick it off. So what is a DDoS attack? Well, it's I'm guessing if you're watching this video, you probably already know this, but just in case you haven't, it is the capability of somebody to go and take over a device. Could be a PC, but it could also be sort of a smart device, a speaker, what have you. If I've got the credentials to run anything that I want on it, I'll go and upload a script. I'll have a lot of these devices, each with their own internet connection, maybe all over the world, and then they will, at the same time, direct a whole lot of nonsense traffic down to your endpoint sitting out on the internet. That could overwhelm that system. It might not be the front-end system that gets overwhelmed, but maybe the back-end repercussions of that. But the idea is that legitimate traffic can't get through to that service because it's having to respond to all of this nonsense. Over time, we can see that here's a picture of what the DDoS attack volume looks like in Azure per day. And what you can see is that over time, we're starting to reduce. There was a big explosion sort of during the peak of COVID, but we're starting to see a reduction there in the duration of longer attacks. That's the top part there, the brighter colors, blues and things. We're seeing a reduction in those longer running attacks, but we see this constant base of attacks that are sort of, under 10, 15 minutes long. Here in Azure, we see a lot of attacks. In fact, we see some of the biggest attacks. We see the biggest attacks in the world have taken place on the Microsoft network. The one on the left side that you're seeing there is around very short-lived attack around, what's it called? The Friday buying period, Black Friday, where for just 2 minutes, the largest number of packets have ever been sent during a DDoS attack. In that example there, that customer was unaffected by that attack. They didn't even know that it had occurred, and Azure was able to go and mitigate that. And then some of the, quote, smaller attacks, still very, very large, we also have received and been able to mitigate those as well. So how are we able to go and mitigate these attacks? A lot of it relies on the Azure backbone network. So this, well, let's take a step back. It's not even the Azure backbone network, it's the Microsoft backbone network, which means that it's the network that services all of our PaaS, SaaS, IaaS services that we offer to our customers. And that could be anything from, yes, Azure, but also Microsoft 365, LinkedIn, Xbox, all of those properties that we have out there that you utilize, they all flow over the same backbone network that we've got different points of presences around in the world. In those blue dots are our Azure regions, but we also have points of presence elsewhere outside of a region, where we've made an agreement, say with a telco, where we might have some equipment out there and we can go and mitigate some attacks even at those points of presences as well. The way that we do that is we have things called scrubber devices that sit all around the world. And before a packet gets onto our network, well, once a DDoS attack is underway and we realize that there could be something to mitigate here, we go and use our software-defined network to redirect some of those packets over to the scrubber devices and now start sending them through that to be verified, right? And anything that is not legitimate traffic will get dropped, and the legitimate traffic, even from the same source IP address, will be allowed to pass through and hit your endpoint. So in that way, we've got an enormous network out there. If one of those scrubber devices becomes overloaded, we can adjust that software-defined network, route them to the next nearest point, and then scrub it there. And in that way, none of the traffic has to go and traverse the rest of the backbone network, overflowing that part of it as well. So we can keep the mitigation quite localized, but enormously scalable. right? The kind of scale that is just too expensive for a customer to implement on their own. So we have some different offerings around the way that we're going to use Azure DDoS. So that picture that we saw before, that provides DDoS protection to all of our IP addresses that are public. So there is effectively a free version of DDoS that's already working. We'll get back to that in a second. First, I want to talk about this one here. This is the main offering of Azure that we're offering for customers for sale. It is an entire network protection. And what that means, this is the one that we led with when we first started selling DDoS. What this means is that we can go and connect our DDoS plan, protection plan, to multiple different VNets, no matter where they are in the world. So whichever Azure region you happen to be using, no matter which subscription of yours you choose to use it in, we can connect all of them up to one plan. So long as there's under 100 IP addresses in there, you'll be paying the same flat fee, and then after that, there's a per IP address fee on top of that. So the first 100 IP addresses that are public IP addresses that pop out of there will be protected, all within the same Azure AD tenant. Some customers have multiple tenants, but this has to be within one of them. That's where the sharing capability kicks in. We have a bunch of features on the side there, on the left side, and we're going to go through those as we progress through. I wanted to introduce you to one more plan that we have also, we've come up with recently, that is a per IP address plan. So what this one does is it says, hey, that 100 public IP address limit that you're talking about, we don't have that many public IP addresses. We only have a handful of them. Maybe we've only got one. The promise of Azure is to pay for what you use. We don't need to use those other 99 protected IP addresses. Isn't there a way that we could have that service too? And that's what the public IP address protection plan is to link to just one public IP address, and you pay a fixed fee for that one. You lose some of the features, and we'll go through in just a minute how those features compare. But it is per single IP address. At the moment, it's in preview. The preview's come quite far now. It's using the exact same technology as the standard plan, as in it's using the same scrubbers and the same machine learning algorithms that we'll be discussing. It's the billing part of it that is in preview at the moment, right? So it's still a very reliable service in that way. Okay, so if we look at the three different ways that we offer DDoS, so if we look at that column, the first one that says always included, that means that, yes, this is the Azure backbone network. So any public IP address is always going to have some kind of DDoS protection. What you're going to start losing when you, what functionality you're going to be missing if you completely rely on that service is that you won't have any metrics. You won't know when it's happened to you. Now, if you have been a victim of a DDoS attack and your company name ends up on a front page of a newspaper somewhere, people will be asking questions, and it's good to be able to give them answers when that has happened. So being able to see when it happened and be alerted to it when it does happen, maybe get the SMS. It's integrated into the standard alerts within Azure. You can get the SMS, the phone call, it goes to your CM solution, your ITIL solution, whatever it happens to be, ITSM solution. We can integrate into all of those. So it'd be really good to be able to know when we're being attacked, right? And that's where the paid plans of the IP protection plan or the network protection plan kick in. The free option applies to every one of our public IP addresses, both IPv4 and IPv6, across all of the IaaS and PaaS solutions within Azure. So if you're running an app service, it would apply to that. Now, the other plans, the IP protection plan and network plan, they only apply to public IP address objects that you've created within Azure. So you've gone into your portal and you created a public IP address object. That public IP address can only apply to certain resources, quite a number of them, but not all. So there's some services that come pre-packaged with their own, like a SQL server or an app service, for example. So they're always only going to benefit from the public version of it, but we can do something else as well. We'll get to what those pictures look like afterwards. So the public preview of the IP address protection plan only applies to standard public IP addresses. So we offer two different SKUs, two different versions of a public IP address object, standard and then basic. Basic means, well, the difference between standard and basic is that a standard can also work across all of the availability zones and be distributed across all of those as well. There's some other features there too, but you need that one for the public IP address plan. Whereas the network plan, hey, we've always had that, so it all applies to all of our types of IP addresses. So what we'll do next is we'll go through some of these different features and what they really are, and hey, is there a value in there for me to be able to consider starting to use one of the paid versions of the DDoS protection plans? One of the best ones that I think is quite cool is that, yes, we are going to be in the free plan, we are going to be looking at the different types of traffic and have mitigations for those. If it's a DNS attack, we have a mitigation for that. If it's a UDP attack where the source of the packet is the destination and we just create a loop, we have identifications for those kinds of attacks. But we're not in the free plan, we're not doing anything specific to your workload. And that's what this adaptive tuning means, is that we're running machine learning algorithms against your traffic patterns all the time to see what is normal for you. So it could be that, for example, you've got an email that goes out every Monday morning. People click on the mail and then they hit your website and you see this big spike of traffic, and that for you is normal. So we don't want the DDoS engine to kick in there and say, ho, 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 this looks like a DDoS attack. No, this is expected traffic, right? That also links with the DNS queries that they made that you're also hosting potentially on your internal network. So we expect to see a bunch of DNS traffic, and we expect to see a bunch of web traffic after that on 443 going to this particular IP address from a large chunk of this part of the world, Europe, for example. That is normal, yeah? So we'll be building up these algorithms to see what looks normal for you so that we can really tune down to be very precise about what it is that we're going to be excluding when it comes to a DDoS attack. One of the other cool features is that you get to see what's going on. All right, so you can go into the metrics part of Azure and see, am I being attacked or not? You can also go in and see what kinds of attacks have been underway. And then you can see these things called flow logs, where you get to see the way that the attack progressed. It went from this IP address to this IP address, from this type of attack to that kind of an attack. And these alerts can be sent over, like I say, to some of your other solutions as well, right? So they can integrate into something else, because what you might find is that an attack is not necessarily an attack. It could be that it's just noise that somebody's trying to create to do some real damage elsewhere. And you really want to get that back into one CM solution like Sentinel to see what was the full scope of what they were trying to do. It also means that you're going to get some, I wouldn't call them false positives, but positive positives that are kind of not so interesting to you. If at 2 in the morning there was a 35-second attack against your network, does that really matter to you? Because, hey, the service was really underutilized anyway. Nobody noticed that it didn't work. Do I want to be woken up then by that SMS? So you need to go and configure your alerts to be able to manage some of those. I won't call them false positives, but yeah, unnecessary alerts, right? So that we only get really high value things that need to be taken action on. So here's a little screenshot of what it looks like. This is the counter that's saying, am I under attack or not? It's 0 if I'm not, 1 if I am. You can see sort of a 10-minute window where we've gone and run an attack for. During that 10-minute time, I've got the next window is sort of scaled to that. This is the traffic that the public IP address attached to that firewall happened to see, much shorter. All right, so the attack did happen. Our metrics kick in. They tell the scrubbers in the software-defined network, hey, you need to go and reroute some packets. And then the illegitimate packets disappeared when the normal packets continued. See that little lump that happened just after that one. So we were able to deal with quite a lot of throughput that was going through there for just a very short period of time. We had some noise, but usually it's not enough to go and trigger a scale out in that time. We can integrate into Sentinel. Like I said, there's an attack pattern where, yes, we will go and make some noise purely for the purpose of making noise so that we can do something that we wanted to do, which was maybe reuse some credentials elsewhere. Right? And it'd be really good if we could have that combined view across Sentinel to say, hey, we saw these types of attacks, and then have that information spit out. One of the other advantages of having a paid plan is that if you were under attack, you can go and download the report of what happened as well, right? Really good for when, yeah, there's been a lot of internal noise in your organization and I need to be able to show back what's been going on. One of the big advantages of having the network protection plan that differentiates that from the per IP address plan is that you get access to something that we call Azure Rapid Response. This is a really high value paid for service of support that you can apply to your individual workloads. It has a really high, really fast response time, 15 minutes from when you raise a case to when you get in contact with an engineer who knows your network. We have a version of that rapid response program for support that comes free, well, comes built into your network plan, not the per IP address plan, but the network plan, where when you go and raise a support case, as we're doing here, look, we chose a service that's called DDoS and we said, hey, we're under attack. When that comes through to us, you'll get a network engineer in 15 minutes who'll be talking to you to say, hey, what else could we be doing for mitigations here? Maybe we could scale out this particular workload. Maybe if we just change the public IP address to a different one, they'll help you with some different mitigations based on what kind of attack that you're seeing to make sure that you're still up and running through that. The ability for us to go and capture that you are under an attack, we're going to back that with a 99.99% SLA. So 0.1%, 0.01% of the attacks that we see, we won't detect. Well, the SLA promise is there, all right? So if you were to have 10,000 attacks, one of them we might not catch. And we're going to back that with a financially backed SLA. The SLA looks like this, that, hey, if that one did attack, you did get attacked during that time, you've paid for the plan, but you got attacked anyway, we'll cover the cost of the DDoS plan for that period. But the cool part about this is, yes, I was under an attack and my services scaled out, right? Maybe I've got a Kubernetes cluster or an app service or an app gateway or a firewall, and it saw a huge amount of packets coming in. The first thing that it did was scale out. Because remember, it's going to take us some time before we go and react, right? 30 seconds, 60 seconds. There may be a possibility of something expanding out, which incurs costs at 2 in the morning when you couldn't control them. Not very fun. So what we also offer that nobody else does is the ability to say, yes, your cost went from a standard cost of $100 a month, and then on this particular day it spiked up to $200. That differential, whatever it is, we'll make sure that you get a credit for that so that you don't have to pay for those expand outs. So to get this up and running fast, okay, so these attacks are happening kind of daily, weekly at the moment in Denmark. How can we take advantage of this if I've got an on-premises service? All right, so the on-premises service and the on-premises service, hey, look, that could also be running in Azure. It could be running at a hosting company. It's just an example, but you get the idea. If I have some firewall at 20.2.2.2.2, and it's being able to redirect traffic, so reverse NAT back to my web server, which talks to a SQL server. What you might find is that the public IP address on the firewall is the one that's receiving the attack, but because it's having to send all these maybe SYN packets back to the web servers get busy. That's one kind of an attack where the web servers might break, but what we often see is that it's not just the web servers that break, it's that the requests that were coming in, they were not just simple TCP connections or simple UDP connections, they were more complicated. They were maybe a web services post in there. That post command goes down to the database has to do some work, and maybe that's the thing that that was the victim of the attack in the end. I couldn't serve out pages anymore because my content management system wasn't working anymore. So really common picture that I think you could relate to probably what you're working with at the moment. What we want to do is say, let's get Azure DDoS in there in the middle, right? Create a nice sandwich between the attacker and you that can go and protect you. So we create a virtual network and we associate the DDoS protection plan to that whole network, or multiple networks if you've got them. You get the idea. In there, I go and create a public IP address object, right? Remember, I have to create the public IP address object. That's the thing that's getting protected by the DDoS plan. But an IP address on its own can't route packets anywhere. It can't do anything. It's just an IP address. We need something smarter down there to go and redirect traffic. One of the options that we could go and throw in is an application gateway. This has listeners for HTTP traffic. So if my backend is HTTP, is web traffic, it's a great option to go and put in. We reference a backend as being a different public IP address. And then what will happen is the traffic will come in, hit that public IP address, so it's been filtered by the DDoS plan, and then go back to your firewall. Yeah. So that's one way of doing it. Now, what we're doing is we're adding in that web application firewall box in there too. That can do something really cool. Our DDoS plan is going to protect you against layer 3 and 4 attacks. Layer 3 means IP addresses. Layer 4 means, hey, which kind of traffic is this? Is it TCP, UDP, which port? Port 80, 443, 53, whatever it happens to be. But we're not going to go any deeper than that on a DDoS plan. So if that was a post command to my website that brought down my SQL server, a DDoS plan isn't going to stop that if it's, say, just 100 of these web requests coming through. If that was enough in 1 minute to bring down your SQL server, a DDoS plan isn't going to catch that. That's where a web application firewall kicks in, where it says, hey, I'm receiving a lot of requests at the moment, and they're malformed search requests. in that name field. There's a lot of them. I'm going to try and break that chain and then stop those HTTP requests from going any further, so that the web application firewall within your app gateway can go and add that layer 7 protection as well. The gotcha here is, hey, if I'm going to put on a web application firewall, it could be that my website is doing things that I find to be legitimate, but the web application firewall, being generic rules, seems to be illegitimate, and it will make some false positive blocks, right? So it'll block traffic that you wanted it to block. That's going to make the people who manage my web servers kind of upset. So I need to make sure that whoever manages this web application firewall is also hopefully the same team that can manage the web pages, to make sure that maybe that web request that I built into my web page, maybe if I write that in a different way, it's not going to trigger on all of these rules. So in my web application firewall, I could go in and say, look, I've got 100 and something different rules. I can put them all to be in alert mode, right? So audit, and it will write a log each time one of them triggers. And I can see every time I go to this one page, I keep triggering on this log, on this error type, right? This vulnerability type. Maybe if I go and change my code, I could mitigate that. And all the rest seem to be clean. I can go and turn on all of those, so that when somebody does initiate an attack that matches one of those weird patterns, our web application firewall can work. And that's another cool benefit of the DDoS plan, the bigger plan, the network plan, where that web application firewall has an additional cost on top of the application gateway. But if it's behind the DDoS plan, the cost of the web application firewall is free. So it's included in the cost of the DDoS plan. So no matter how many of them that I have, right? So if I really needed to scale this out, imagine if you're a hosting company and you've got lots of these different on-premises services that you're hosting for customers, I could maybe build a scale-out solution in between and be the broker for them and offer these sort of t-shirt-sized services back to my customers and say, hey, we're going to add in some DDoS for you that we're going to manage as an additional service. So I might have different web application gateways for web application firewalls for different customers with different configurations. All of them would be free. The web application firewall part, the app gateway part, you'd still need to pay for. We'll get to the cost of that at the end. Another way of doing that, right? So it could be that you already have an express route circuit. So wouldn't it be cool to be able to add in services that don't need to hit that public IP address, that 20222 that's sitting on my firewall? Wouldn't it be cool to have a service that can go through that? So and one of them could be API management. API management's a really heavy-duty service. It's got a lot of cool functionality in there. It's got the rate limiting and quotas and policies and things like this. It's got scale-out. It's got schema validation. There's all kinds of cool things that you could be doing inside the API management that's really targeted for where my back-end pool, my web services, are running APIs rather than full-page web services. API management comes in different flavors. There's a premium, standard, developer, fourth one I can never remember the name of. If you're running the premium or the developer edition, they have the ability to integrate into a VNet, which means they get one of those private IP addresses in my virtual network, and they can now access the express route and go that way. What the cool part of this model, and you could just as well do it with the app gateway, is that I can take that public IP address, the 20222, I can now take that one away. So that even if somebody remembered from the last time they attacked you that you had this public IP address in the end, you can go and get rid of that if you've got the ability to go and send your traffic through the express route, for example. Another way you could solve this same problem is the two first examples were great if it was actually web traffic, right? So HTTP-based traffic, APIs and full-page web services. What if I'm hosting a service on my backend that is neither of those, that still needs to be published out publicly? So a DNS server, for example. That's UDP, port 53. App Gateway isn't going to help you. We could put in something like an Azure firewall instead. The downside to Azure firewall is, hey, we don't know what kind of traffic is in there. We're not going to terminate the SSL. We're not going to be able to look inside the packets. It's just used as a routing engine to get those packets back onto your network. The only reason we're using Azure Firewall, again, is just because public IP addresses can't route. We need something else. It would be cool if we had a PaaS service that could route. There's probably other PaaS services we could use for this. There might be gateways and things that we want to put in. Keep it simple. Azure Firewall could be the thing that could help you there. There's still more ways of doing it, because we have a service that offers a DDoS functionality, but doesn't fit into any of the models that we've talked about. Azure Front Door is a service that we use to go and publish our web endpoints to make sure that traffic coming from all over the world, remember that whole global picture, we have points of presence around the world. Front Door can terminate through the equipment that's out there, those SSL sessions out there in the wild world, and then do some CDN caching and we can add a web application firewall down in those particular areas. And the idea being that, hey, I'm getting all these requests from all over the world. My Front Door instance that's spread out all over the world too will go and offload a lot of that workload to the local location where the user happens to be. And their web requests go really, really fast for them. The latency to what they think is the backend is much faster because it's actually really, really geographically close to them, which means that it's also a possibility for people to direct attacks against it. Now, it's using public IP addresses, just as every other service in Azure, so it's going to have DDoS, the free version, covering all of its endpoints out on the internet. But it's going to be kind of invisible to you, right? So you're not going to get those same level of metrics and cost back benefits and rapid response and these sorts of things. They're not going to be there. But it is going to offload the DDoS protection for you. So you could put in Azure Front Door Premium, put a private link on there if you've got ExpressRoute, and then send the packets down through to your network like this. That's one way of solving the DDoS problem, right? That's another way of doing it. In that case, say the web application firewall, we can go and add these custom rules to the Front Door version of web application firewall around rate limiting. So you can define, from any particular public IP address coming in, I want to have a maximum of, say, 200 requests per minute. And then the web application firewall will kick in and drop those for you. All right, so custom rules. Hey, and Front Door Premium, there's a bunch of other rules as well that we bake into it because we have our the Microsoft Threat Protection technology that's going to be populating that rule set, the automatic rule set that's in the web application firewall, to fill it up with all kinds of good stuff, things like bot protection and things, right? So we know about a bunch of bad actors on the internet already. We're going to take all of that information around the current bad IP addresses and then filter them into all of our customers' web application firewalls so we can take advantage of it at scale without having to go and manage that ourselves. So that's going to be coming in there too. So there's a lot of advantages to having that web application firewall. If you don't have the ExpressRoute, we could do that in a different way again, using Front Door. Front Door Standard, hey, that doesn't have the ability to have a private link. It can still forward it onto your public IP address, right? So we're doing security by obscurity again, but it's a way of filtering things. One of the bigger downsides we've come across with using Front Door, though, is that you get allocated not a public IP address, you get a DNS name. And now you need some DNS service to go and take your Apex DNS name, your contoso.dk, for example, not www, just contoso.dk, and then map that over to the name that Front Door gives you as a CNAME redirect. Not many, Azure, for one, is one provider that will not do CNAME redirections for Apex domains, so you need some other service to do that for you. But it's another way. It's sitting on the shelf, ready to go, something you can get going in a day. Changing gear a bit. So if we've implemented one of these plans and we need to test that it's going to work before we switch over, the final switch over for our IP address and DNS so that people can start using it, would be a good idea to just do a quick check. Is this working? So there's a bunch of providers. I think there's 3 different providers out there that we've partnered with, where we allow you to go and create a test account, a demo account, direct it to the public IP address that you've set up, run a quick attack against it, and then gather the metrics and then see the alerts coming in and how did it flow all the way down to sending me an SMS, right? Test it all the way through to make sure that you're ready to go before you switch over. If you are, so I had that picture back before where I said, hey, this is your on-premises network. You could have this on-premises by a hoster. You could also be Azure services. It could have been app services as well, right? You can put in the DDoS layer there. If I don't want to use that app gateway, I still want to have a DDoS protection, my app service will be protected by DDoS. It's just not going to be visible to me. None of the benefits are going to be there. What I could do, though, is implement something to the underlying layer of app services called the Kudu system, right? Replaced IIS, where I could put in some dynamic IP restrictions. So I enable an add-in, and I can set in some dynamic restrictions. Where this is super useful is, yes, I have the app services layer, people are hitting it, and it's sending traffic down to my database, and that's the one that's getting overloaded. I could just put in this one as like a quick and dirty way of saying, I need to protect my database service here and now. So let me go and put in a way of preventing my app services from overloading it, because app services can scale out, and that becomes I'm enabling the DDoS attack effectively by amplifying these web requests that are coming in from the internet. Other tools that you can use to get yourself ready. We have the EASM tool within Azure. Anyone can go and spin this one up, free for 30 days. You type in your company name and it will give you your public profile of what you look like to the internet. So we'll go and scan across all of your ASN numbers and all the IP addresses in there and all the SSL endpoints that might be behind there, and look for things that other people might be looking for. So you can get an idea of what does our picture look like to the outside world? What things could I go and be mitigating already now to try and prevent people from exploiting anything that might be easily low-hanging fruit for them. So go do a quick investigation there. We also integrate DDoS into a bunch of tools. So Defender for Cloud is in there, Sentinel is in there, and this is the link in for Azure Firewall. When I go and create a new firewall, I can also say the VNet that you're connecting to with that public IP address, hey, we want to connect it to the existing plan. You can put that in through policy as well. So every time I go and create a firewall, it will link to that specific DDoS plan for you. So you're always covered. We have that 30 to 60 second delay from when an attack happens until the attack is mitigated by Azure by rerouting our traffic in the network and hitting the scrubbers. There's some scenarios where that's not good enough. We need it to react really quickly. The big one that we would talk about there is if you are a gaming company and you're hosting your gaming servers. If I'm a player and I'm about to go and I know that there's a guy around the corner that I want to shoot him and take all of his stuff. What I might do is swipe up, launch a quick attack, 5-10 seconds against his port that he's using. He can now no longer interact with his game. I can jump around the corner and then, hey, whoop-de-doo, I'm golden. We've got a new service that we're coming with for no latency delays, so that every single packet that's going into your game service is hitting one of our gateway load balancers and then gets passed through scrubbers, the same technology that we're using for DDoS. We've partnered again with A10 for that one, and then filter that traffic back through the gateway and then down to your game service, so that everything is getting filtered out, so that little sneaky attack will mitigate those ones too. All right, so this is in public preview. If you're doing, say, trading as well, this could also be like a last second trade before the markets close, for example, right? Want to be able to block those. There could be other different scenarios that you could think of too. That's all I explained. So let's jump to the pricing. How much does this stuff cost? So we talked about the DDoS network protection plan, the big one for 100 IP addresses. It's $3,000 a month. And if we go above that, for each IP address, it's $30. We have the IP protection plan, which is now being charged for. While it was in the early stages of preview, it wasn't. It's now being charged at $200 a month, or $199 per IP address. So that makes your cost benefit switch over at 15 IP addresses, but you might find that there's added value in the network protection plan that means that I probably want to switch over to that earlier than that, right? What were the three benefits there? There was cost protection, the WAF mitigation cost, and the rapid response support, right? Having access to those three might mean that I want to switch over to network protection plans earlier. If I am going to put in a gateway, something in between to route the packets, here's a couple of examples of what they could cost you as well. So for an app gateway, you have a fixed cost, as in the gateway exists at all, of 26 cents for West Europe. Most of my customers are using West Europe. I might want to add in the web application firewall. You can see it's almost about 2x the cost of just having the gateway itself. So the DDoS plan would be mitigating all of that stuff in the right-hand column there. And then I need capacity units. So effectively VMs that are hosting it, they can scale out as well. You can go down to, I think you can go down to 0 even, but you could have 1 through 10. I might be wrong there. It can scale out in that way, right? So you pay for each one of those. If we were going to use the firewall instead, higher cost, right, per hour that we're going to be running this for, but much more flexibility when it comes to the different types of protocols that we could use, right? The previous example of that gateway, hey, we can only use web-based traffic. This one can use anything TCP, anything UDP. So that's kind of all I wanted to walk you through. I hope that's helped you a lot. So we just talked about the different plans, something around the adaptive tuning, very cool, rules specifically based for you, based on machine learning, the telemetry you're going to see coming out of metrics and alerts, the rapid response plan, so support is available to you within 15 minutes of an attack. You'll be talking to somebody. We've got those cool cost protections, both in, hey, we scaled out, and I've got the WAF cost mitigation in there too. Multiple different ways of getting Azure DDoS working. So yeah, if you find this interesting, we have a link. I think, did I put a link to it? Yes, to aka.ms/staycalm. What that is an office form that'll come back to technical people like myself at Microsoft Denmark, who can then reach out to you, right? So there's a way for you to get in contact with us, even if you don't know how to go and figure out who is your Microsoft representative to keep you safe. So I hope that was helpful to you, and talk to you soon. Bye-bye.